Alright, so let's remind ourselves of a derivative rule that if we have the derivative of the sine of u, think of that as just being a formula of x's. Well, how do we do that? Bueller? Bueller? Anyone? Alright, it's just the cosine of that formula, but don't forget we're not quite done yet because of the chain rule. What do we need to add on? The derivative of whatever was inside that formula. Okay, well, let's now say this and take it into the integral realm. So we can use the fundamental theorem of calculus to say that if we want to know what the area formula is of cosine u du, in other words, the indefinite integral, the fundamental theorem of calculus says that's just the same thing as the antiderivative, so it must actually be the sine of u. But am I missing anything? Don't forget we have to add on the constant. That's our plus c lemma. Alright, so let's actually apply this to a problem. So let's say we have the integral of x cubed cosine x to the fourth plus 2 dx. So this looks long and complicated, but it's actually not that bad. So first I'm just going to rewrite it in a slight way. So all I'm going to do here is take the x cubed and put it at the end instead of in front. And it turns out, knowing that I'm about to use this, I'm going to actually space things out a little bit. So I'm going to go ahead and scoot that over a little bit. And actually thinking ahead a little bit, I also need a little bit of space in front of the integral, so I'm just going to scooch that over a tad. And the reason why I did this is because if you look at this formula that we just were looking at a minute ago, so this says if you're taking the integral of cosine of a formula, as long as you have the derivative of that formula afterwards, you can use this shortcut. So that almost matches up what we have here. So we've got the cosine of a formula, but I can't just right away say, oh, that's going to be sine, because to be able to use this shortcut, you have to have the derivative afterwards. And I don't quite, right? Because what is the du in this case? What's the derivative of what's inside the cosine? Well, the derivative of x to the fourth plus 2 is 4x cubed. And I just have an x cubed. I'm missing a 4. So we have to do what I call play the wishing game. So since we wish there was a 4 there, just go ahead and write a 4 there. Now, of course, that actually has now changed the problem, because there wasn't really a 4 there. So to balance off the fact that we just threw on a 4, we actually have to put a 1/4 right next to it. So now we actually haven't changed the problem, because doing 1/4 times 4, that's just 1. So I haven't changed anything. Just throwing a times 1 in the middle of the problem keeps it the same. Well, it turns out I don't really need that 1/4 right there. All I really cared about was that 4. So I'm going to go ahead and pull the 1/4 outside the integral. That's one of those integral properties that we know about. We can just pull coefficients outside. So I'm just going to go ahead and do that. So now let's look and see what we have here. So we've got the u part matches up with x to the fourth plus 2. And in fact, the du part now exactly matches, now that we've added on this 4. Or not actually added on, multiplied it on. So because we have attached this 4 on here and balanced it off with the 1/4 on the outside, this now matches our du, because the derivative of the inside the cosine is now outside here, just like it says to do on the formula, which means we can go ahead and proceed with what we know the answer is. Now, just don't forget that there's still that 1/4 that's out there. So we got to go ahead and put that on there. But now the rest of the answer we can proceed and just say, okay, it's the sine of, well, what is it the sine of? It's the sine of u, but what really is u? It's x to the fourth plus 2. Then we go ahead and tack on the plus c. So let's go ahead and put this all together and distribute that 1/4. So 1/4 the sine of x to the fourth plus 2 plus 1/4 c. But as we pointed out in the previous video, if you just have a constant times another constant and c represents any constant, then this is still just any constant. So mathematicians are lazy and just have this c be a cannibal and gobble up any other constants next to it. So 1/4 c is actually just c. Alright, although it's technically not required, let's do a little double check that our answer is actually correct. So we're claiming that if you take the integral of x cubed cosine x to the fourth plus 2 dx, that comes out to be 1/4 the sine of x to the fourth plus 2 plus c. So one thing I also want to point out is that this x cubed kind of mysteriously disappeared. It's like, well, I kind of see how the cosine became a sine, but what happened to this x cubed? Students ask that a lot. So, well, let's kind of investigate exactly what happened to that. So one way we can double check this is correct is by taking the derivative of this and seeing if we get back to this formula. So if we're trying to take the derivative of 1/4 the sine of x to the fourth plus 2 plus c, well, what do? Well, the first thing to notice is that this 1/4, that's just a coefficient, so that has no effect when we take the derivative, so we can just pull that down. And next we have to take the derivative of the sine of a formula. Well, what's the derivative of sine of a formula? Well, according to the chain rule, you take the derivative of the outside part, keeping the inside the same. So let's go ahead and do that. Derivative of sine is cosine. We keep the inside the same, so still x to the fourth plus 2. But we're not done yet because, according to the chain rule, after you take the derivative of the outside, keeping the inside the same, you still have to multiply by the derivative of that inside. Well, the derivative of that inside would be 4x cubed plus 0, right? The derivative of x to the fourth is just 4x cubed, and the derivative of the plus 2 is plus 0. So that takes care of the derivative of the stuff in purple. Then we also have to take the derivative of our plus c. Well, that just goes away. So we've got a number of zeros in here. Now, normally in real life, people probably wouldn't write these zeros. I'm just putting them on for emphasis about where things came from. So let's just go ahead and get rid of those. So let's get rid of that plus 0 there, and get rid of that plus 0 there. And we notice there's one other simplification we can do, because, everything here is basically multiplication. We got a 1/4 in front and a 4 right here, so we can just cancel those. So what's left? Well, it's just this stuff in blue here, and let's go ahead and write this x cubed in front. So what we have is that when we take the derivative of what we were claiming the antiderivative was, we actually get x cubed cosine x to the fourth plus 2, which is exactly the integrand of what the original question was. Oh, by the way, in case you're not familiar with that term, integrand means the formula that's after the integral sign. And notice you can kind of see now why that x cubed disappeared when we were doing the wishing game here with this integral. And it's the same reason, because this is essentially the backwards chain rule, and it's the same reason why this x cubed appeared out of nowhere from when we did the chain rule. So when we took the derivative in the forwards direction, the x cubed suddenly appeared. So when we do it backwards, when we're doing integrals, the x cubed was there, and then it goes away. All right, very briefly, let me show sort of a more formal way to do what I call the wishing game with U substitution. So if we're going to do this same exact problem, pretend we don't know what the answer is. Let's go back to the original integral. So the integral of x cubed cosine x to the fourth plus 2 dx. So the more formal way to do this, rather than sort of wishing for the 4 there, is you say, well, I got the cosine of a formula here, so let's give that a name. So off to the side, you say, all right, I'm going to let u equal x to the fourth plus 2. This process is called U substitution, because in the end, we're going to rewrite the integrals just with u's instead of x's, and should hopefully look nicer. Well, if u is x to the fourth plus 2, so now by differentiating, that means that du is 4x cubed dx. Now, one way you might be used to seeing this is back from the very start of Calc 1 when we were doing derivatives, we would say du dx, or du over dx, is 4x cubed, but now we're thinking of it in terms of differentials. So we just say du is 4x cubed dx. It kind of looks like you multiplied the dx over. Not exactly what was going on, but it's a good mnemonic. Okay, so let's go back to the original problem now. Oh, sorry, back up. So before I do that, kind of looking ahead to what I want, I'm going to go ahead and rewrite this by dividing the 4 over, so we have 1/4 du is equal to x cubed dx. Now let's go back to the original problem, and based on what I just did a second ago over here, I'm going to change the order of how I wrote it. I'm going to put the x cubed together with the dx, put it back here so the cosine's out in front. So now it looks more like this. So before we just sort of said, oh, we'll wish for the 4 in front, and it looks exactly the same, but doing U substitution sort of does that thinking for you, right? It just sort of says, hey, when we replace this with u's, look what's going to happen. Well, over here, it's going to be cosine of u. And what's going to happen to this x cubed dx? Well, the x cubed dx is exactly 1/4 du. So we didn't actually have to wish for it. It just automatically happened here. And now we can just go ahead and integrate this. So let's get rid of this 1/4. We can pull it outside the integral sign. It's just one of those integral properties right there. So we know what the formula is for the integral of cosine u du. I'm being a little lazy here, not putting my parentheses as part of the function notation, but that's fairly typical actually. So if we want to do the integral of cosine of a formula, and you've got the du after it, we know that it's just going to be sine u. So we've got 1/4 the sine of u, and then tack on the plus c. But we can't leave our answer like that because the original question didn't have x's in it. The original question didn't have u's in it. It was just with x's. We made up the u ourselves to be able to see how to do this integral. So we actually have to write the final answer only with x's. So 1/4 sine of, and I just replaced the, sorry, I'm having pointer issues today. So we replaced the u with x to the 4th plus 2 because that's what it's equal to. Now everything's back in terms of x's as desired.